This example, we're going to look at a special case where we might have two different triangles that will satisfy the situation, and this is because of the angle side side situation. Okay, so if you recall when we had ASS or SSA, this is what can kind of happen. So we can have a triangle that comes down like this, and this was, the pretty traditional triangle. We're going to consider this to be an obtuse triangle up here. So this is going to be 30 degrees. This is angle A, and this is angle B, and this is angle C. And so we know B is 7. We don't, nope, this is 6, sorry. This is 6, and this is C, and this is side C over here. So what can happen though, because we're given an angle, a side, and a side. And what we can know can happen is we can end up having an acute angle coming off at C. So we can come down here, and 6 could be over here, or 6 could be here. So it ends up being this ends up being an obtuse angle down here. Okay, so let's kind of I'm going to erase that red line over here for a second, because now we can see it. So I'm going to come over to here now and draw that second triangle that we could have. So I'm going to still have the second triangle coming in here. This angle is still going to be 30. This is still angle A. This length is still 6. This length is still 7. This is C. This is angle B. Okay, so what we're basically going to end up with, in this case right here, we have angle B is acute, and angle C is obtuse. Okay, in this angle, in this situation over here, we're going to end up with angle B is obtuse, and angle C is acute. Okay, so when we go to solve this, we're going to end up with two different triangles and lengths. Okay, so let's kind of think about what we have so far. I'm going to kind of put in the middle here what we have, and when we solve them, I'll move the information to the middle. Okay, we know that A is 6. We know that B is 7. We don't know what C is, but we know I'm going to get two different answers for C, because C is going to be a really small length or a large length. So I'm going to get two different answers that C could be. I'm going to get that angle A is 30 degrees. I don't know what angle B is right now, and I don't know what angle C is, but I'm going to be able to get two different answers for each of these. B could be two different results, and C could be two different results. Okay, so let's just use the law of sines for over here. Okay, so I've got my 30 degrees and my 6, and I want to find angle B, but I know this is 7, so I'm going to use the law of sines for that. So I've got my angle B, and I've got 7. Okay, so if I set up my ratio, I'm going to say that the sine of 30 over 6 equals the sine of B over 7. Okay, and I want to find out what B is, so I'm going to say that the sine of B is going to equal 7 times the sine of 30 over 6. Okay, so then I'm going to take the inverse sine, so I'm going to say B is equal to the inverse sine of 7 times the sine of 30 over 6. So that's going to give me that B has an angle of, comes out to be 35.7. Okay, so in this case it'll be, so B comes out to be 35.7. Okay, so I just found 35.7, and then if this length is 30, nope, B was 35.7, then I would just do 180 for angle C. I'm going to take 180 minus 30 minus 35.7, and that's going to give me 114.3. So I get 114.3. Okay, and now I need to go ahead and find side length of C. Okay, so I need to find this length of C. So I'm going to use red again. So I'm going to use that the sine of 30, the sine of 30 over 6 equals, okay, now I've got to do side length C. So I know that C was 114.3 over side length of C. So I'm going to say that that equals the sine of 114.3 over C. Okay, so now I'm going to cross multiply and get C over the sine, C over 6 equals the sine of 114.3 divided by the sine of 30. So C is equal to 6 times the sine of 114.3 over the sine of 30. Okay, and if you put that into a calculator, you're going to get that C comes out to be just about 10.94. Okay, so I'm going to go up here and put C is 10.94. Okay, now we're going to do the other triangle and the other 3 pieces of information. Okay, knowing that we've got to find this angle instead. All right, so since angle B is obtuse, I can take 180 minus 35.7, and that gives me that angle B is 144.3. Okay, so angle B comes out to be 144.3, and I just took that by taking 180 minus 35.7. Okay, and then I need to find angle C now, so I'm going to take 180 minus 144.3 minus the 30 degrees, and that gives me angle C being 5.7. Okay, so now I have all the angles, so I'm only missing side length C now. So I'm going to use that ratio of the sine of 30 divided by 6, and let's use C now. So I have angle C is what I know, angle C is 5.7, and I need to find length C. So I'm going to say that's equal to the sine of 5.7 divided by C. And now I just run through the algebra. I'm going to switch C over 6 to equal the sine of 5.7 divided by the sine of 30. And I'm going to get C to equal 6 times the sine of 5.7 divided by the sine of 30. When I do that, I end up with C is approximately 1.19. So that's my other piece of information, that C comes out to 1.19. And now I've solved it. I have 2 different values for some of these answers, and that is an example of the ambiguous case.